Hello friends and welcome to Edupedia World Videos. This is the course Basics of Programming in C language and we are in the chapter 12 part B of this course, and in this course we will be learning about the recursion in C. So till now we have covered functions in C language. Now we will learn another concept using functions which is known as recursion. So first of all, what is recursion? Recursion is a property of a programming language to allow the function to call itself within its own body. Okay, so one function can call itself inside the same function's body. Okay, so that is known as recursion, and recursion is not only confined to C language, it is provided by many other programming languages also. Okay, and this enables the programmer in creating another kind of loops known as recursions. Since one function is calling itself again and again, okay, so it will cause a mirroring effect. Okay, if you stand between a place where there are two mirrors on the opposite walls, so what will you see when you look at one of the mirrors? You will see infinite number of images. Okay, so that is the same way, because the function within itself will call the same function, so it will repeat infinite number of times till you cancel it, till you break out of it using some conditions. So we will learn about how recursion is used on our next slide. Okay, so this is a function that we are using for recursion. The function is FCTL. So what this function does is it will calculate the factorial of a particular number. So for those who are not familiar with what factorial is, well, a factorial is the product of all the numbers from 1 to that particular number. So suppose we are talking about the number 5. So the factorial of 5 will be 5 into 4 into 3 into 2 into 1. So 1 to 5, all the numbers you multiply them and then you get the factorial of 5. Factorial of 10 would be 1 multiplied by 2 multiplied by 3, so on up till 10. Okay, so that is what factorial means. Okay, so now this function we have for calculating the factorial, and what we do is we will calculate the factorial using recursion method. So this is our function FCTL, and we have an integer argument to it because we are dealing with numbers, so our data type will be integer, obviously, int num, and here the brackets begin. Okay, then we have a condition: if num is less than or equal to 1, then you have to return 1. Okay, so I'll explain this condition in future in detail, but for the time being just assume that suppose we have passed one single digit 1 to this function, so the factorial of 1 would be 1 multiplied by 1, that is 1 only. Okay, so in that case we have straight away put a check that okay, when you reach 1 or whenever user enters 1, you have to return straight away 1. Okay, so if this is not true, the number is not less than or equal to 1, the number is greater than 1. So what we will do is we will return num, whatever the number is, multiplied by FCTL num minus 1. So this is the same function called again over here within the body of the same function, but the argument we have changed, and the argument now is num minus 1. Okay, so if num was 10, then here 10 is passed, and FCTL 10 minus 1, that is 9, is called again. So again this function will be called with an argument of 9. It will again come over here. It will not enter this condition because it is not true. So it will again come return num multiplied by FCTL num minus 1. So num minus 1 would this time be 8. So it will again return 8. So it will become 10 multiplied by 9 multiplied by 8. Okay, and this way it will run up till the condition 1 is achieved, up till the num value becomes equal to 1, and at that time it will return 1. Okay, so we will see this in a while. Till then, let me explain you one more concept over here, that the factorial of 0 is 1. In mathematics, by the rules of mathematics, the factorial of 0 is 1. So in this case, suppose the user enters the number as 0. Okay, what will happen is we will compare this condition if the number is less than or equal to 1. Okay, so in that case the number would be less than 1. If the value of num is 0, it would be less than 1. So in that case also we will return 1. Okay, so now let us see what happens if we enter 5 to this program. Okay, so suppose we take num as 5 initially. What will happen is we will come over here, we will compare this. If num is less than equal to 1, no, 5 is not less than or equal to 1, so we will not enter this condition. We will straight away go to return num into fctl num minus 1. So what will it do? It will say return 5, which is our num, into fctl num minus 1, num which is 5 minus 1, which is 4. So 5 into fctl of 4. So let us see what happens on the next step. Again, factorial of 4 will be called. So here we have 4 for the next iteration. Here again this condition is false, so we will skip it. We will come over here and it will say return num into fctl of num minus 1 again. Okay, so that will make it 5 into 4 into fctl of 4 minus 1, that is 3. So this part from over here to here has been generated in the second function call. Okay, within this iteration, in the second function call, these two things have been added. In the first function call, what was there? It was 5 into fctl of 4. In the second function call, we have got 5 into 4 into fctl of 3. Similarly, when we come over here, fctl of 3, this function will get called again. Okay, the same function will get called again in the body of the same function, but this time the argument is again changed. It is now 3. 4 minus 1, 3. So here we will have 3 here. Then we will say if num is less than 1. No, this is not less than or equal to 1. So we'll skip this condition again. We will come to return num into fctl of num minus 1. So it will again return 3 into factorial of 2. 3 into factorial of 2. So again this process will continue, and this time factorial will again get called. fctl function will again get called with an argument of 2. Okay, so it will say if num is less than equal to 1, 2 is not less than equal to 1. So again we will skip this line, and again this particular line will be called, and here we will again have 5 into 4 into 3 into 2 into factorial of 1. So this particular two statements, 2 multiplied by fctl of 1, has been added in the latest iteration. Okay, so again see, our whole factorial series is now getting generated, and what will happen this time is we will call fctl function again with the argument 1. Okay, so now when it is called with an argument of 1, this condition becomes true. Okay, number less than equal to 1, 1 is less than equal to 1, 1 is equal to 1. So this condition will become true, and in this case this line will not get called because we will return from here itself. Okay, so return is the last statement of a function. Returning means that that function will not remain in scope again, so the context will switch back to the calling function. Okay, so whatever function, wherever we would have called this function for the first time, we will reach over there on the next line. So what will happen is we will ultimately return 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, because the last time this will return 1, so last iteration will not return 1 into factorial of 0. It will just return 1 as per the condition over here. So our target has been achieved. Okay, now this value is obviously equal to 120. Okay, so this was the theoretical part of it. Now let us try and do this particular thing practically. So let me open the IDE code blocks for this, and we will write a small program for factorial using recursion. Okay, so I will start a new project, console application as usual. Then we will select the C compiler, and we have to name our project. So let us name it as Factorial. Okay, rest of the options I am keeping it as default. So here our project is now ready. I am opening the main file, and I do not need the default hello world statement, so I am deleting it. Rest are the include statements. One is stdio.h, which we have included, which is standard input output.h. It has functions like printf, scanf, etc. Then there is another file which is standard lib.h. So we might not use this file. We can remove that one. Okay, so now our shell, or the outer template of our program, is ready. Here is our main function which is returning an integer, because in C language main function is bound to return an integer to the operating system. Okay, and we have included a default return statement also, which says return 0, which will be the last statement of our main function. Okay, so now we will have to first create our factorial function which we will be using for recursion. So its return type will obviously be an integer, because it will return an integer. Let us name the function as fctl, as we have done in our example recently. So its argument would be, what would be its argument? It would be again an integer, int num. So this is the body of this factorial function, and what we will do is we will, let's check what was there in our slide. Okay, so here in our slide we had a condition that if num is less than equal to 1, then we have to return 1. So the same thing we will apply over here. If the value of num is less than or equal to 1, in this case we have to straight away return 1. Okay. In another case, when this condition is not true, then we have to return num multiplied by, now we have to call recursively the same function again, fctl. So the same function gets called in the body of the same function, and the argument that we have to pass is num minus 1. So why minus 1? Because what factorial is, it is n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 up till 1. Okay, so till you reach 1 you have to carry on this multiplication of multiplying the predecessor of that particular number with that same number. Predecessor means just the number that comes before it in mathematics. Okay, so 10 multiplied by 9 multiplied by 8 multiplied by 7, 6, 5, 4, 3, 2, 1, so on. That is how we have to do. So that is why we are subtracting 1 from this number while passing the argument for the next recursive call. Okay, so this is what we have done. Now let us see, let us now take an integer value. So we will take the number n equals to 5. Okay, so we have initialized it with the value of 5 so that the factorial of 5 will get called. Now what we will do is we will use our printf statement to print the factorial of 5. The syntax of the printf statement is first the keyword printf, then double quotation marks, we have a constant string along with some format specifiers. The constant string would be like whatever the message you want to print on the screen. So the message is the factorial of %d, which is a format specifier for integer, and it will be replaced by the value of n. Okay, so we'll write over here n, which is our first parameter that we have to print, first variable that we have to print. So %d, first %d will be replaced by n. Okay, so the factorial of n is, here we will again write %d and comma. So what will give the value of the second %d or the factorial? It will be the call to the function fctl n. So that is done. Now this function fctln will return an integer value when it executes, and that integer value will be substituted in place of the second %d. Okay. So that is how our program should now work. So let us see if it works or not the way we intended to. First step towards it is to compile it. First is save it, and then we have to compile our program. Let us see if we get any errors. Yes, we have got an error. So let us see what the error is. We return over here. Okay, so now saving it and building it again. Okay, so now our code has compiled with 0 errors and 0 warning. Let us try and execute this code and let us see it prints 120 or not. So if it runs correctly, our program should return 120 and it should print that message on the screen. Okay, so it has printed the factorial of 5 is 120. So that is what we expected it to work as. Okay, it has returned the right amount. So now what we will do is we will try and run this program in the debug mode to check it out in detail. the functioning as it continues to execute. Okay, so what I will now do is that I will apply a breakpoint within our code. So let us apply a breakpoint in our function fctl, okay, in the first line. And what is a breakpoint? A breakpoint means that whenever I execute this program in a debug mode, it will first halt over the breakpoint, and from there on I can control the execution of that code. So I can press a button, so one line will get executed at one time, at one click of a button. Okay, so I can see how the flow goes. So to execute this program in a debug mode, I have to click to this debug button over here. Okay, so I will come to know that this particular program has started execution when there will be a yellow triangle over the breakpoint. Okay, so here it is, and now what I have to do is I have to press this next line button over here to go to the next line. Okay, so since it was in this condition over here and the value of num for the first time was 5, okay, because we have passed 5 over here, so it was 5, so it was greater than equal to 1, this condition was false. That is why it has not entered this bracket, this block. It has straight away come to the return num into factorial of num minus 1 statement. So let us now again go to the next line. Let's see where it goes. Now what it should do is it should again enter. What we have to do is we have to step into this particular function from fctl num minus 1, because only when we step into this particular function we will be able to see what is happening inside it, because again we are calling the same function. Okay, so what we have to do is step into. Okay, so again it is at our first line and it is checking for the condition. It is again false because now at this time the value of num would be 4, so we can just print it and check it out. Yes, it is 4. Okay, so now we go to the next line. Again this condition was skipped and it is in return, so what we will do is we will again press step into. Okay, again we are into this particular function, and at this time the value of our num would be 3, because we have called the argument with the function with the argument num minus 1. So our earlier num was 4 and num minus 1 is now 3. Okay. Similarly, now go to the next line again and step into again. Okay, so this time what it would be, again the value of num would be decremented by 1 and it would be 2. Okay, so the same thing we do again and step into the function again. This is the last time that this function has got called, and at this time the value of num would be 1. Okay, now see the execution. It will not go to this return statement, but it will rather go into this condition because num is equal to 1 at this time. So this condition is true. It will go over there and it will return from there. Okay, yes, as expected, it has come to line number 8 and it is now returning 1. So as I press next line, it will return 1 and it will exit this function after this. Okay. So now why it is coming to this line so many times? Because all these times, okay, this function was called, so now all of these functions are returning, all of these functions are exiting. Okay, first time it got called when I called it from here, second time it got called again from here, third time again from here, fourth time again from here, and fifth time it returned from over this line, 8th line. So now the fourth call will return, then the third call will return, and so on till all the calls return. It will not go back to here, and when all the calls return it will go back to here and print our result. Okay, so this was the last call that has now returned. Okay, so now it has come back to our printf statement and it has printed our result, and then when I press next line the function will exit. So now it has exited after printing our result. Okay, so I hope that the concept of recursion was clear to you. What we can do is in our next video we will do one more program based on recursion, so you can even brush this concept up more nicely. I hope you continue to watch the course Basics of Programming in C language. Thank you.